In this video, we are going to be working a bearing problem in which we will solve for time abeam to an object. Before we get started, let's take a look at some of the tools you'll need to solve this problem. First, you'll need a pair of dividers. You'll need a parallel ruler, and you'll also need a maneuvering board. Note that you'll be using the 2-to-1 scale on the maneuvering board. Okay, so now that we have our tools covered, let's take a look at the problem we'll be solving. To solve this problem, you'll follow 8 steps, shown on the right side of your screen. So let's begin. Step 1 is to plot your initial course and initial time. Looking back at the problem, we can see that this information is given to us. So first, write down your initial time of 10:37 at your start point. Now, using your parallel ruler for precision, you will draw a line for your initial course of 246 degrees true. With your initial course plotted, you can now move on to step 2. Step 2 is to plot the location of the object. Again, refer to the information given in the problem, and you can see that the object is located on our initial course at a distance of 14 miles. So first, let's figure out what 14 miles will look like. For this, you'll slide over to your scale and use your dividers to measure out 14 miles. Now, bring the dividers over to the initial course line and make a mark along the line at 14 miles. So now we've done the initial course, the initial time, and the location of the object. Now we can move to step 3. Step 3 is to determine the safety zone. The problem tells us that we're going to be 2.5 miles off Abeam to port. So that means we're going to leave the object 2.5 miles to port, or off our left side. So slide back to your scale and use your dividers to measure out 2.5 miles. Then, bring that back over to the location of the object and draw an arc to represent your safety zone. Step 4 is to determine our new course. You'll need your ruler to do this. Take your ruler and plot a straight line from your start point so that it just barely touches the top of the arc you drew for your safety zone. In this case, that gives us a new course of 256 degrees true. Draw this line as exactly as possible. You can see that our new course is just barely outside of 256. Now that we have our new course plotted and the location of the object, we can move on to step 5. Step 5 is to determine the point at which the object is abeam with the ship. This means we will be finding the point at which the object is exactly 90 degrees from the ship's heading. So again, use your ruler here to measure out 90 degrees, and then make that mark on the new course. That is our point abeam. Now we can find the distance between our starting point and our point abeam. So in step 6, we determine the distance to the point abeam along our new course. For this, place your divider on your start point and measure out to the mark you drew for the point abeam. Then, slide over to your scale and identify the distance. We come up with a distance of 13.8 miles. Again, try to be as exact as possible. Now we have our distance and our speed, which was given in the problem. Step 7 is to determine how long it will take us to go from our start point to the point abeam. For this, use the formula time equals distance over speed. So time would equal 13.8 miles over a speed of 12 knots, which gives us 1.15 hours. We'll need to add this duration to our initial time, so we have to convert it from hours to hours and minutes. So 1.15 hours would equal 1 hour, 9 minutes. In our final step, step 8, we apply the duration to the initial time. Take the initial time of 10:37 and apply the duration of 1 hour, 9 minutes. This gives us a time of 11:46. This is our final answer.